Okay, so here's a lesson for section 5.3. This lesson is all about calculating the slope of a line segment. So what I want you to do to start this lesson, I want you to go to jensenmath.ca and download this lesson, print it off so you can follow along and copy out this lesson as we go through. What I want you to do to start this lesson is I actually want you to try and complete this investigation on your own. Before you can try and complete it, just make sure you've read the definition of slope. Okay? The slope of a line is a measurement of the steepness of a line. So make sure you know that whenever you see the word slope, what it's talking about is the steepness of the line. So in the following diagrams, I've got three ski hills. Ski hill A, B, and C. Each of them have different steepnesses. Okay? So I'm just kind of drawing a squiggly line through each of the hills. Okay? You can see each of them have a different steepness. Okay? I want you to use this information it gives you to try and figure out what the steepness of these hills actually are, and I want you to rank these ski hills in order of their steepness from least to greatest. So I want you to try on your own to try and figure out a way you could actually calculate the steepness or the slope of these three ski hills and figure out how you could rank them from least to greatest using some type of algebraic method. After you've done that, okay, so I want you to pause it now and try it, and then after you've done that, I want you to check the answer page from jensenmath.ca to see if you got it right, okay? So pause it now and try it. Now that you've actually tried that investigation, what I'm going to do now is I'm going to actually go through this lesson and show you how we actually find the slope of a line. And hopefully after you went through that investigation, you were able to determine on your own how you can calculate the slope of a line. If you weren't, I'm going to go through now actually how you do that. Okay? So remember, the steepness of a line is measured by its slope. Okay? So I told you that slope is the steepness of a line. How do we calculate slope? Well, the slope is actually the ratio of the rise to the run. Okay? And is often represented by the letter m. Now, I haven't told you what rise and run are yet. I'll tell you that in a second. Okay, you might be able to guess just by the words. But what I want to talk about right now, you notice we use the letter m to represent the slope of a line. If you remember back to the previous two lessons about partial variation and direct variation, remember direct variation has an equation of y equals mx, and we use the letter m there again, and we use that to represent the constant of variation. So I want you to, hopefully maybe you can start making this connection now. So the constant of variation actually is the slope of the line when we graph it, okay? And we'll keep making this connection between the two of them as we go through these lessons over the next couple of lessons anyways. Okay, so I just put this here. You should maybe be starting to make the connection. What else do we use the letter m for? We use the letter m for the constant of variation. So there's going to be a lot of connections between slope and constant of variation. Okay, so I've told you that slope is the ratio of the rise to the run. What is rise? What is run? Okay, well, rise, so if we've got 2 points and they're connected by a line, rise is actually the vertical distance between the 2 points. So the vertical distance is our rise between these 2 points. And run is the horizontal distance between these 2 points. Okay, so this is our run. And rise is the change in y, because if you think rise, the vertical distance, we know our vertical axis on a grid is y, and our run is our change in x, because we know the run is the horizontal distance between 2 points, we know the horizontal axis is x. Okay, so you might be making another connection right now. Okay, remember when we calculated our constant of variation before, we used the equation m equals change in y over change in x. And I've just told you calculate slope by doing the ratio of rise to run. And we know rise is change in y, run is change in x, so slope is actually change in y divided by change in x as well. That's another connection showing that the constant of variation is in fact the slope of a line. Okay, so here's that equation there. Slope equals rise divided by run, so the ratio of rise to run. Or we can write that as change in y divided by x, because rise is the vertical distance between 2 points, so the change in their y coordinates. and run is the horizontal distance between 2 points, which is the change in their x-coordinates. So you could write it either way. Rise divided by run, or change in y divided by change in x. Okay? So when we're talking about slope, we'll usually use rise divided by run. When we're talking about, in the previous lessons we talked about constant of variation, and we used the formula change in y divided by change in x. Okay? But they're in fact the same thing. Okay? Because rise is the vertical distance, which is the change in the y-coordinates. Run is the horizontal distance between 2 points, which is the change in the x-coordinates. Okay? So when determining the rise and run of a line, so if I give you the graph of a line, I want you to determine the slope, you're going to need to find the rise and the run. You must know that. Okay, so when you're finding the rise or the run, you're going to start at, so a line is a segment that connects 2 points. So if this is my line segment, it connects these 2 points. Okay, I must figure out my rise by starting at one of the points. You can start at either point, doesn't matter, you'll end up with the same answer in the end. You're going to start at one of the points. If then to get to the other point, you must count in the upwards direction. See, if you have to count in the upwards direction, you're going to have a positive rise. If you have to count in the downwards direction, you will have a negative rise. And I'll give you some examples of this in a second, so don't worry. If when you're doing run, to get from one point to the other, you count, you're counting units to the right, this will give you a positive run. If you're counting units to the left, this gives you a negative run. Okay? So let's see what some examples of this look like. So example 1, count units on the grid to determine the rise and the run. So here's my line, it's connecting points A and points B. Okay? So to get from point A to B, let's count my rise. So I have to, point A is down here. I know my rise is the change in the y-coordinates, change in y, so it's the vertical distance between the 2 points. So I want to calculate the vertical distance between point A and point B. And I've laid that out for you here by making this right angle triangle. So the vertical distance, it goes 1, 2, 3 units. Okay, so my rise, and I'm counting in the upwards direction, notice. So that's positive 3. My run, my horizontal distance, I've laid that out as well. I go to the right 1, 2 units. And I'm going to the right, that's positive as well, so my run is 2. What is the slope of the line? Well, I know slope equals rise divided by run, so my slope is, in this case, 3 over 2. And that's my answer, and you're done. Okay? Example 2, let's look at this line. Once again, I want the slope of line CD. So I want the slope of the line that connects point C and point D. So I need to figure out the ratio of the rise to the run. So to get from point C to point D, I need to figure out what the vertical distance between the 2 points is and what the horizontal distance between the 2 points is. So the vertical distance is the rise, so getting from C to D, I must go down 1, 2 points. So I'm going down 2, that means the rise is negative 2. And then I must go right 1, 2, 3 points. Okay? Going to the right 3, that means the run is positive 3. What is the slope of the line? Well, slope equals rise over run. Therefore, my slope is negative 2 over 3. And that's my answer. Now, let's try and make the connection between what the graph of the line looks like and what the integer value of the slope is going to be. So looking at example 1, is the slope positive or negative? So this line from A to B, the slope was 3 over 2, so that has a positive value. That's positive 1.5. Okay, and if you notice, if you look at the graph, the line from A to B going from A to B, it goes up to the right. So if the line goes up to the right, it's going to be I have a positive slope. Okay, so for example 1, it had a positive slope. What direction does the line go? Up to the right. And that's true for any lines that have a positive slope. They're always going to go in the direction up to the right. Example 2. Example 2, the slope was negative 2 over 3. Okay, negative 2 over 3. That is, so the slope has a negative value. And if we look at the graph, going from C to D, the line is going down to the right. So in example 2, the slope was negative. What direction does the line go? It goes down to the right. Okay, so conclusion about positive and negative slopes: a line that blank has a positive slope. So if it's a positive slope, the line that goes up to the right has a positive slope, and a line that goes down to the right has a negative slope. And that's true in all cases. Okay. Before I go on to do this, find the slope of vertical and horizontal lines, I just want to show you something here. Okay. Let's look back, because you might be asking this to yourself right now. For this question here, let's look at example 1 again. You might be saying, okay, so the slope of line AB, what if we counted the rise and the run if we were starting at A and then going to B. To get from A to B, we had to go up 3 and right 2. So our rise was 3, our run was 2. What if I started at B and went to A? Would that change my slope? So what if I started at B and then went to A? Okay? To get from B to A, I'm going to have to go left 2 and then down 3. Okay? So that would mean that my rise, so I went down 3, my rise, I know going down gives me a negative value, and my run, I went left 2, so that gives me a negative value when I go left. So my rise would be negative 3, my run would be negative 2. That means my slope would be rise over run, which is negative 3 over negative 2. And you know when you have a negative divided by a negative, the negatives cancel, and it's just positive 3 over positive 2. Okay, because negative 3 divided by negative 2 equals 1.5, and 3 divided by 2 also equals 1.5. So negative 3 over negative 2 is the same as positive 3 over positive 2. And this is in fact the exact same answer we got when we went from A to B instead of from B to A. So when you're calculating the slope of a line, it doesn't matter which point you start at. Okay, so you could go from A to B and calculate your slope, or go from B to A and calculate your slope. You'll get the exact same answer in the end. Okay? So now let's continue on slopes of vertical and horizontal lines. Okay? So part 2, find the slope of a vertical and horizontal line. So let's do this through a bit of an investigation here. Plot the points A and D on the graph provided and connect the points to form the line segment AD. So point E is at 1, 1. I know every coordinate gives you the x coordinate first and then the y coordinate. So point 1, 1 means when x is 1, y equals 1. So that's this point here. And point D, so I'll label that point A. And point D is 0.51. So that means when x is 5, y is 1. So when x is 1, 2, 3, 4, 5, y is equal to 1. So that's point D. And I remember that the vertical axis is the y-axis, the horizontal axis is the x-axis. Okay? So let's connect these 2 points to form a line. Hopefully you can see this. I'm just going to slide it over to connect them better. Okay, so I've connected points A and D. Now it wants me to determine the rise and the run of line AD. So to get from point A to point D, how much am I rising? Am I going up or down at all to get from A to D? No, I'm not at all. Okay, it's just it's directly to the right of it. It's not going down or up at all. So my rise is in fact 0. The run, so what's the horizontal distance between these 2 points? The run, I go 1, 2, 3, 4 units to the right. So my run is positive 5. Okay, so my run is positive 5. I know slope equals rise divided by run, so 0 divided by 5, 0 divided by 5 equals 0. So my slope for this horizontal line is 0. And in fact, the slope of any horizontal line is always going to be 0. Why? Because the rise of any horizontal line is going to be 0, because there is no vertical distance between 2 points that are connected by a horizontal line. Okay? So slope of any horizontal line equals 0. Now let's do a vertical line. So let's plot the points E15. Let's plot the point E15 on the same grid. So on the same grid, point 15, that means when x equals 1, y is equal to 5. So 1, 2, 3, 4, 5. Here's point E. Connect those points with a straight line. I'll just move it to get it connecting them better. Hopefully you can see that. So I've drawn a line connecting points E and A, and you'll see that's a completely vertical line. Now it's going to ask me for the rise and run of line EA. So what's the rise to get from point E to point A? So to get from point E to point A, I have to go down 1, 2, 3, 4 units. I have to go down 4 units. So my rise is negative 4. Going down 4, going down in the downwards direction gives you a negative rise. My run, so run is the horizontal distance between 2 points. Do I have to go to the right or to the left at all to get from point E to point A? No, you don't at all. Okay, there is no horizontal distance between 2 points on a vertical line. So my run this time is 0. I know slope is equal to rise divided by run, so negative 4 divided by 0. And hopefully you know now you can't divide a number by 0. Okay, if you try and do that on your calculator, it'll say error, or it might say undefined. And that's what you get whenever your denominator is 0. So when you try and divide something by 0, we in fact say the slope is undefined. Okay, so the slope of any vertical line is undefined because the run to get from one point to the other on a vertical line is always going to be 0. So you're always going to be trying to divide by 0, and we can't do that, so we say that the line has an undefined slope. So any vertical line has an undefined slope, and any horizontal line has a slope of 0. Okay, let's practice finding slopes now. So if I want to find the slope of this line connecting these 2 points here, I need to figure out what the rise is and what the run is. Now I can start at either of these points. I'm going to call these points A and B. I can start from A and go to B, or vice versa, go from B to A, and I will get the exact same answer for slope. I'll probably do both for this example. So let's go from A to B to start with. So to get from A to B, I have to go down 1, 2, 3, 4. I have to go down 5 units. So the vertical distance between 2 points is the rise, and I'm going in the downward direction, so it's negative. I went down 1, 2, 3, 4, 5, so it's negative 5. The run is the horizontal distance between 2 points. I have to go right 1, 2, 3, 4 units to the right, so the horizontal distance between the 2 points is 4. Going to the right is a positive run, so my run is 4. So my slope is rise divided by run, so negative 5 divided by 4. Okay? Now, let's say instead of going from A to B, we calculate the slope by going from B to A. I'll show you what happens. So let's just get rid of all of this. So if I'm going from B to A, my rise, I'm going to have to go up 1, 2, 3, 4, 5 units. When I go in the upward direction, I'm going to have a positive rise, and the vertical distance between the 2 points is 5, so my rise is positive 5. My run is the horizontal distance between the 2 points, so to get from B to A, I have to go left 1, 2, 3, 4 units. So going to the left gives me a negative run, so it's negative 4. So my slope is rise divided by run, which is 5 divided by negative 4. And 5 divided by negative 4 is the exact same thing as negative 5 divided by positive 4. Okay? If you put that on your calculator, either one of those two things, you'll get negative 1.25. Those have the exact same value, so in fact these are the exact same slopes. And When you get an answer with a negative sign in the denominator only, you should actually move that into the numerator or put it out front of the fraction. So you should actually rewrite this as negative 5 over 4 or negative 5 over 4. Those all have the same value. So in fact, we got the same answer no matter whether we went from A to B or B to A. Okay? All of these things, they all equal negative 1.25. Okay? That shows you they all have the exact same value. Put all of these on your calculator, you'll get the same value, so all of these are the same slope. So it doesn't matter what direction you go in. If you go from A to B or B to A, you'll get the same slope. Okay, so this one, let's find the slope of the line connecting these 2 points, A and B. So to get from point A to B, I have to go up 1, 2, 3 units. So my rise is 3, going the upper direction, I know it's going to be positive. And then I have to go right 1, 2, 3, 4 units. Okay, going to the right gives me a positive run. I know the run is the horizontal distance between 2 points, so it is a run of 4. So my slope is rise divided by run, so my slope is 3 over 4. Good, and look, this line goes up to the right, and I have a positive slope. I know that's always going to happen. And remember the previous line went down to the right, and I had a negative slope, okay? And I know that always happens as well. Last example we'll do. The ramp at a loading dock rises 2.5 meters over a run of 4 meters. So it gives me the rise. It gives me the run. It asks me to calculate the slope of the ramp. You can use this diagram to help you. It shows you the horizontal distance. So here's the ramp. We're looking at the slope of this line right here. It gives you the horizontal distance from one end of the ramp to the other end. So it gives you the horizontal distance between those 2 points. And it also gives you the vertical distance between those 2 points. So it gives you your run and your rise. We can calculate our slope by doing rise divided by run. That'll give you the steepness of the slope. So we're going to do 2.5 divided by 4. And if you do that, you can put that on your calculator and actually evaluate what that is. 2.5 divided by 4, and you'll find that it equals 0.625. So the slope of this ramp, or the steepness of that ramp, is 0.625. Okay? And I think that's it for the lesson. Okay? So the main thing I want you to take away from this lesson is that the slope of a line, we use the letter M to represent slope, and it equals rise over run. Okay? And rise is the vertical distance between 2 points, or the change in the y-coordinates, and the run is the horizontal distance between 2 points, or the change in the x-coordinates. So remember, y is the vertical axis, x is the horizontal axis. Okay, so those are the main things from this lesson. Make sure you try the worksheet from jensenmath.ca and let me know if you have any questions. Other than that, I think that's it.